We will discuss latches and flip-flops today. Latches and flip-flops are the basic elements of any sequential circuit. It is basically a one-bit storing device. In case of latch, output can be affected by change in the input, and flip-flop is basically a latch with clock input. So output of flip-flop can be affected by clock input. We will start with S bar R bar latch. It is basically a cross coupled NAND gate circuit where output of first NAND gate is the input for second NAND gate and output of second NAND gate is the input for first NAND gate. It's like a feedback connection. Output of first NAND gate is denoted by QT and output of second NAND gate is denoted by QT bar, which means the output of two NAND gates should be complement of each other. This circuit can be redrawn like this also. Output of first NAND gate, that is QT, is the input for second NAND gate and output of second NAND gate is input for first NAND gate. This input is S bar and this input is R bar. So this is the circuit diagram for S bar R bar latch. Here NAND gate is used. So in NAND operation, two inputs are A and B. Output of NAND gate is unique when all the inputs are high and the unique output is 0. And if any one of the inputs is low, then output of NAND gate is high. We will use this to write the state table or characteristic table for SR flip-flop, S bar R bar latch. Let's see characteristic or state table. In this table we write present state, inputs and the next state. Present state is denoted by QT or Qn. Inputs are S bar and R bar. Next state is denoted by QT plus 1. Now let's see first state. When present state is 0, qt is 0, so qt bar has to be 1, s bar is 0 and r bar is also 0. S bar 0, R bar 0. Now here both the inputs are same and both the inputs are 0 for NAND gate. If we know that if any one of the input of NAND gate is 0, then its output has to be 1. So qt plus 1 next state is 1, and for second gate output is also 1. qt plus 1 bar is also 1. And in this circuit, the output of NAND gate should be complement of each other. But in this case, both the NAND gates are giving the same output. So this state is invalid state. Now we will check the next state or next condition. In the next case, present state is 0, qt is 0, so qt bar is 1, s bar is 0, r bar is 1, s bar is 0, r bar is 1. We'll find out the output of first NAND gate first. So this qt bar is the second input for first NAND gate, that is 1. 0 NAND 1 is 1. So qt plus 1 is 1. Now output of first NAND gate is the input for second NAND gate, that is 1, and 1 and 1 is 0. qt plus 1 is 1 and qt plus 1 bar is 0, so this is valid state. So we will write next state as 1. Now let's check the next case. qt is 0, qt bar is 1, input s bar is 1, r bar is 0. Again, let us find out the output of first NAND gate. First, qt bar is the input for first NAND gate. 1 and 1 is 0. So this qt plus 1 is 0. Now output of first NAND gate is the feedback input for second NAND gate, that is 0. So 0 and 0 is 1. So qt plus 1 bar is 1. This is again valid state because qt plus 1 is 0 and qt plus 1 bar is 1. So next state is 1. Now we'll check the fourth condition. In fourth condition, qt is 0, so qt bar is 1, s bar and r bar both are 1. qt bar is the feedback input for first NAND gate, and 1 and 1 is 0. And this QT plus 1 is feedback input for second NAND gate. 0 NAND 1 is 1. This is also valid state. QT plus 1 is 0. So this cross coupled NAND circuit or any latch or flip-flop will give invalid state only if the two inputs are same. So flip-flop or latch will give invalid state for 0 0 or 1 1 only. And if the two inputs are not equal, then we will have a valid state in case of flip-flop or latch. Let's check the fifth condition. QT is 1, QT bar is 0, S bar and R bar both are 0. Again, input for NAND gate is one of the input for NAND gate is 0, so output has to be 1. So QT plus 1 is 1 and QT plus 1 bar is also 1, which is invalid state. So again we will get invalid state when both inputs are 0 0. QT is 1, QT bar is 0, S bar is 0, R bar is 1, S bar 0, R bar is 1. QT bar is the feedback input for first NAND gate, that is 0. So output of first NAND gate is 1 and this QT plus 1 is the feedback input for second NAND gate, that is 1. So 1 and 1 is 0. QT plus 1 bar is 0, which is valid state. So QT plus 1 is 1. Now present state is 1, QT is 1, QT bar is 0, S bar is 1, R bar is 0, S bar is 1, R bar is 0. QT bar is the feedback input for first NAND gate, 190 is 1 and this QT plus 1 is feedback input for second NAND gate. So here again 190 is 1. It seems to be invalid state because QT plus 1 and QT plus 1 bar both are 1. But when the two inputs are not same, then we cannot get the invalid state. So in this particular case, we will find the NAND gate of second, we will find the output of second NAND gate first and then output of first NAND gate. I will show you how. We'll find out output of second NAND gate first. So this QT is the feedback input for second NAND gate, that is 1. 190 is 1, so QT plus 1 bar is 1. Now this QT plus 1 bar is the feedback input for first NAND gate, that is 1 1. 1 NAND 1 is 0, so QT plus 1 is 0. QT plus 1 is 0 and QT plus 1 bar is 1, so this is the valid state, that is 0. Now let's check the last condition. QT is 1, QT bar is 0, S is 1, S bar is 1, R bar is also 1. QT bar is the feedback input for first NAND gate, 190 is 1. Now this QT plus 1 is the feedback input for second NAND gate, that is 1, and 191 is 0. So QT plus 1 bar is 0. So this is valid state, next state is 0. So this is the characteristic table or state table for S bar, R bar, latch. With the help of this table, we can make S R latch using NAND gate. S R latch. Here we will use inverter. So this will be the circuit for SR latch, and its state table or characteristic table. Present state QT, inputs are S and R, next state is QT plus 1. When both inputs are 0, S and R both are 0, when both our inputs are 0, the next state is 0. When S is 0, R is 0, next state is 0. When present state 0, S is 1, R is 0, then next state is 1. When both inputs are 1 or high, next state is invalid state. When present state is 1, both inputs are 0, next state is 1. When present state is 1, S0, R1, next state is 0. When present state is 1, S1, R0, then next state is 1. When both inputs are high, then invalid state.